In this next section, we're going to take a look at arithmetic sequences. So the formulas that we're going to use for arithmetic sequences, we've got two of them. We've got the explicit, and then we've got the recursive. So the explicit is the one that I want you to work with. The explicit is going to be a sub n is equal to a plus the quantity n minus 1 times d, where d stands for the common difference. So d being the common difference just means what is the difference between each of the terms? It's always going to be the same difference if we've got an arithmetic sequence. Now, if we're looking at the recursive, we would have a sub 1 is equal to a, and then a sub n is equal to a sub n minus 1 plus d. You may need to use this at some point, but we're not going to worry about it in here. So let's take a look at an example of how to use the explicit formula to find a certain term in a sequence. So you're given the sequence 2, 6, 10, 14, and 18. If you have 2, 6, 10, 14, and 18, we can see that going from 2 to 6, we're adding 4. If we're going from 6 to 10, we're again adding 4, and adding 4. And you can see that because of the ellipse, this is going to continue. This pattern is going to continue on to infinity forever. So the 4, the plus 4, that represents our common difference. So we know that d is equal to 4. Now let's say that we want to find the fourth term in this sequence. We're just going to verify that this explicit formula works. If we're looking for the fourth term in the sequence, we're going to say a sub 4 is equal to a. Now a is going to be a sub 1. This is the first term in the sequence. So 2 plus, and then we're looking at n. So n, we're again saying, is the fourth term. So we're going to go 4 minus 1 times our common difference, which is 4. So we get 2 plus 4 minus 1 is 3 times 4. 3 times 4 is 12, plus 2 is equal to 14. So let's take a look. First term, second term, third term, fourth term. Fourth term is 14, and that is what we got using our explicit formula. So this is how you can end up finding basically any term in a given sequence. So now we're going to take what we learned about arithmetic sequences and apply it to the first problem in the book. In problem number 1a, we're given the sequence 3, 6, 9, 12, and 15, and we're asked to determine is this or is this not an arithmetic sequence. So again, remember that what you're looking for with an arithmetic sequence is that we have a common difference. So as we move from one term to the next, we always have the same difference, or we're always adding or subtracting the same number. So to get from 3 to 6, we add 3. 6 to 9, we add 3. 9 to 12, we add 3. And 12 to 15, we add 3 as well. So we know that d is equal to 3. So yes, this would be an arithmetic sequence. Now let's look at problem number 1b. In 1b, we're given 1, 4, 9, 16, and 25. So to go from 1 to 4, we add 3, but to go from 4 to 9, we add 5. As soon as we see that we've got a difference there, that where the common difference is actually different, then we know that that is not an arithmetic sequence, and we can stop right there. For problem number 2a, we're given a short sequence of just 6 and 11. We're told that it's an arithmetic sequence and that we need to find the 100th term of the sequence. So even though we're given just two numbers, we should be able to do this fairly easily. So let's go back to our formula, which is again a sub n equals a plus n minus 1 times d. So the first thing that we need to establish is, what is the common difference? Well, to get from 6 to 11, you're going to add 5. So we're going to replace this d with 5. Now, inside, again, what we're looking for is the 100th term. So we're going to go a sub 100 equals, and the first term in the sequence is 6. So 6 plus 100 minus 1. And so I'm going to do a little bit of mental math on this. What we're going to do is we're going to just go ahead and try to simplify this a little bit. 6 plus 99 times 5. 100 times 5 is going to be 500. So if we take one of those 5s away, which would give us 99 5s, that's going to give us 495. So we end up with 6 plus 495, which is 501. So the 100th term in this sequence is going to be 501. You can see how if you take the SAT and you're given one of these questions, it's really going to help you to know that this formula is the explicit formula for finding an arithmetic sequence. It's going to be a lot faster than trying to count 100 terms to get to 501. Now in problem 2b, we're given a little bit different problem here. And we're asked to find these two terms, the middle two terms in between 100 and 82. So here's how I want you to look at this. I want you to say to yourself, what do we have to do to get from 100 to 82? We have to subtract 18. So there's a gap of negative 18 right there. Now, how many terms away from 100 is 82? We're going to make one jump, two jumps, three jumps. So what we know is that negative 18 is being divided by 3 because there are 3 terms there. So if we divide negative 18 by 3, that's going to give us negative 6. So we know that every time that we move from one term to the next, we're going to be subtracting 6. So 100 minus 6 gives us 94, and then 94 minus 6 gives us 88, and just to check our work, 88 minus 6 gives us 82. So there are your solutions right there, 94 and 88. In problem number 3, we're asked to do the same thing that we did in problem number 2b, which is to find the missing term in the arithmetic sequence. Now, because we're only missing one term this time, we can use something called the arithmetic mean. The arithmetic mean is something that you've probably used for 10 years or so. The arithmetic mean just means average, okay? So when you take the SAT, you're going to see all the time on there that it says, what is the arithmetic mean of such and such? All it's asking you to do is to find the average. So whenever we do the average of something, all we're doing is taking all of the terms and we're dividing by the number of terms. So it's going to be like an plus a n or sub n plus 1 dot 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 over the number of terms. And so really all it is you add up all of the terms and then you divide it by the number of terms. So in this case, we've only got 2 terms, so all we're going to do is add the 2 terms and then divide by 2. So this becomes 15 plus 59. See if I can make a real 5 there, divided by 2. So 15 plus 59 is going to give us 74, so 74 over 2 is 37. So the missing number from this piece is 37. Again, remember that this is called the arithmetic mean, and you're going to see that on the SAT, but all it means is find the average. Add up all of the numbers in the sequence, and then divide by the number of numbers in the sequence, or the number of terms in the sequence.